All right, today we're going to be looking at 3.2, which is solving linear systems algebraically. So we're going to be doing the same thing that we did in 3.1, except we're not going to be using graphs and tables to solve systems. We're going to be solving them algebraically. So our essential understanding is that you can solve a system of equations by writing equivalent systems until the value of one variable is clear. Then we'll substitute that value into the other equation to find the other variable. Now, when we say equivalent systems, we're talking about this right here. So equivalent systems are systems that have the same solution. So essentially what we're doing is we're going to be modifying those equations to be not a different value. They'll still be the same line. The equations are just going to look different. So we're going to rearrange or maybe increase numbers or whatever, but it's going to have that same value, which means it would graph to be the same line. So we're going to start with solving by substitution, and we need to know the difference between substitution and what we're going to do in a few minutes, which is elimination. So in substitution, our first step is going to be to solve one of the equations for one of its variables. So we're going to have two equations, and we're going to need to pick one of those equations and then get either the x or the y completely by itself. So we're going to pick one or the other. So then once we've done that, then step 2 is going to be to substitute the expression we just got in step 1 into the other equation and then solve for the other variable. Once I know the value of that one variable that I find in step 2, then I'm going to take that value, substitute it into the revised equation from step 1. So what we got up here when we got the variable, one of the variables by itself, we're going to take the value that we got in step 2 and we're going to plug it back into that equation that we found in step 1. Now, you could technically plug it into any of the equations, but it's going to be the easiest if we take that value from step 2 and plug it back into the equation that we get in step 1. So let's take a look at an example and see what we get. So for step 1, we're going to choose one of the equations and we're going to solve it for either x or y. Now we always want to do the one that's the easiest. So look for what is going to be the easiest to get it by itself. Which equation, which variable. And so what I'm looking for when I go to find that is I want to find one of the variables that does not have a number in front of it. So the only one that I have in this whole system with a variable with no number in front of it is right here. I have that positive y. So yes, technically it's a 1, but I don't have to get rid of it. I just have the y. So I want to use that equation first. So I'm just going to rewrite it. 2x plus y equals 10. So I'm using this equation in step 1. All right, now, if I want to get the y by itself, then all I have to do is get rid of the 2x. So if I subtract 2x, that will cancel out our positive 2x. And then I also have to subtract 2x on the other side. So if those 2x's are gone, then all I have left over here is the y. And then we've talked about this before. Normally, I like my x term to be in the front. So I'm going to have my negative 2x in the front, and then my 10 is positive. So that's going to be plus 10. So that's step 1. I have one of the equations with one of the variables by itself. We have solved for y, which means now I'm ready for step 2. So step 2 is to substitute the expression. So this expression that we just got in step 1, we're going to substitute it into the other equation. So our other equation is 3x plus 4y equals 12. So we're going to take this expression and we are going to plug it in. Since we solved for y, that means we're going to plug that expression in for y. So we're going to plug it in right there. So we're going to have 3x still, but it's going to be plus 4 times that expression from step 1. So all of this right here. So negative 2x plus 10. And then we still have that equals 12 on the other side. Now, if we look at what we have left here, once I plug in that expression into our other equation, all I have left, the only variable I have left is x. I don't have any more y's. The y's are gone, which means I'm able to distribute, combine like terms, and solve, and I can actually figure out what x would equal. So the first thing I want to do is distribute my positive 4, which means I'm going to leave the 3x alone. Then I'm going to do 4 times negative 2x, which is going to give me a negative 8x. Then I have 4 times positive 10 is a positive 40. And then that still equals 12. Okay, so now I can combine. I notice that I have 2 x's on one side of the equation. Now, if I take those 2 x's and I combine them, 3x minus 8x is a negative 5x. Then I still have my plus 40, and it still equals 12. All right, now I'm able to start actually solving for x. So I know that the negative 5 is the last thing I'll get rid of, which means the 40 is the first thing I get rid of. So I subtract 40 on both sides, and that's going to give me negative 5x equals a negative 28. And so you can always grab your calculator and do 12 minus 40, and you'll get negative 28. Now, the last thing I need to do to actually solve for x is to divide by negative 5 and divide by negative 5. So then, again, we're going to grab our calculators because that fraction does not simplify, and that's kind of an ugly fraction. So we're going to grab our calculators, and we're going to do negative 28 divided by negative 5, and then that is going to give us 5.6. All right, so we have a value for x. So step 2 is done. Now we go back up here and look at step 3. So step 3 says to substitute the value from step 2, that's that 5.6 that we just got, into the revised equation from step 1. So that's going to be this equation that we got over here. So then, if I plug that in, then I've got y equals, so step 3, I'm plugging into this equation. So I have y equals negative 2 times 5.6 and then plus 10. So grab your calculator again, and you're going to type that in, negative 2 times 5.6 plus 10, and then that is going to give us a negative 1.2. So now I have an x-coordinate and I have a y-coordinate. Therefore, I've got where those two lines would cross if I were to graph them. So I still need to write my answer as a coordinate point. I'm just not graphing, but it's finding the same solution as if I were graphing. So the x is 5.6, comma, and then my y is negative 1.2. Be careful when you're writing your answers that you always have the x first and then the y. So this is your answer. Now, we can check our answer always. So if I take 5.6 and I plug it in here, I take negative 1.2, I plug it in here, and I do the math, it should come out to be 12. If I plug 5.6 in here and negative 1.2 here, and I do the math, grab my calculator, it should equal 10. So you can always check your answers and know if you're correct. All right, so let's take a look at number 2. We're going to do the same thing. So we want to figure out which one of those would we want to solve for which variable. So remember, we're looking for which equation has a variable without a number. So the first equation has x with no number in front of it. So that's the one we want to use in equation 1. So we're going to use this in step 1. So step 1, we're going to take x plus 3y equals 5, and then we're going to get the x by itself. In order to get the x by itself, I need to get rid of the 3y, so I'm going to subtract it. Then I also need to subtract it on the other side as well. So then, if these 3y's cancel, then we have x, and then it equals, again, those are not like terms. They cannot be combined. So I'm going to put my negative 3y first, And then this 5 is positive, so that's going to be plus 5. So step 1 is done. X equals, I'm going to write it a little bit more normally, x equals negative 3y plus 5. So this 3y plus 5 is what's going to get plugged into the other equation for step 2. So we're going to use the other equation for step 2. So then that is negative 2x minus 4y equals negative 5. And then remember, this expression is going to get plugged in for x. So then I'm going to plug it in here. So I've got negative 2 times, and then x, according to step 1, is negative 3y plus 5. Then I still have the minus 4y behind that, and it still equals negative 5. So now, just like on the other one, I'm going to distribute, and then I'm going to combine like terms, and then I'll be able to solve. So first thing we want to do is distribute that negative 2. So if I have negative 2 times negative 3y, that's going to give me a positive 6y. Then if I have negative 2 times positive 5, that's going to give me a negative 10. Then I still have that minus 4y behind it, and it still equals negative 5. Now I have two y's on the same side, so I can combine the 6y and the negative 4y. So if I do 6y minus 4y, that's going to give me 2y. And then, so I've used both of those, and then I still have that minus 10, and it still equals negative 5. Now I'm finally ready to actually start solving. So if I want to get the y by itself, 2 is the last thing I'll get rid of. So the first thing I get rid of is the 10. So if I add 10 to both sides, then that gives me 2y equals 5. Then I know I need to divide by 2. And so y equals 5 divided by 2 is 2.5. All right, so we have our y value. Now we just need to get our x value. So remember, we're going to take that y value and we are going to plug it into that revised equation that we got in step 1. So that means we need to plug that 2.5 in right here. So then that means x is going to equal negative 3 times 2.5 and then plus 5. So negative 3 times 2.5 would be a negative 7.5 plus 5. And then negative 7.5 plus 5 gives us a negative 2.5. So we have an x value, we have a y value, which means we have an answer. So our answer is x, which is negative 2.5, comma y, which is positive 2.5. And so then that's our solution. Remember, make sure that it is always x first, then y. And again, you should be able to check your answers by plugging them in. If you plug in negative 2.5 here, positive 2.5 here, do the math, it should equal 5. Plug in negative 2.5 here, positive 2.5 here, do the math, and it should equal negative 5. All right, so then we're going to do one more problem using substitution, and that's going to be a word problem. Then we'll move on to elimination. So it says, a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee are shown in the advertisement, so this lovely little picture right here. What is the cost of each lesson and the one-time fee for materials? So first thing we do is define our variables, always. So then we're going to say that, let's say we have C and F for fee, because we are finding the cost of each lesson. So actually I'm going to make it L for lesson, and then I'm going to make it F for the fee. So those are what we're finding, so those are our variables. So we're going to write down here L is the cost of one lesson, and then F is the cost of the one-time fee. All right, now we're going to write our equations. So that's where our picture is going to come in. So we can see that 6 lessons is $300. Well, that $300 includes the 6 lessons, and it also includes the one-time fee. So if I've got $600 equals the cost of 6 lessons, so that's 6L, plus the one-time fee. Then the second option we have is 12 lessons, which is $480. So, oops, that was supposed to be 300. I'm so sorry. So this should be 300, not 600. It was $300 for 6 lessons. All right, the other one is 12 lessons for $480. So $480 will get you 12 lessons, and that also includes the one-time fee. So now we have a system. Now we can solve this using our 3 steps from substitution. So step 1, I'm going to pick one of those equations and get, I'm going to say F by itself because there's nothing in front of F. Now since both of our equations have nothing in front of X, I can technically choose either one. I'm going to say let's just go ahead and pick the first one. So for step 1, we've got 300 equals 6L plus F. So if I want the F by itself, I need to get rid of the 6L. So I'm going to subtract 6L, and I'm going to subtract 6L. And some people really don't like having it reversed. If that's the case for you, then we can always change it, and that's fine. So if I want to put the 300 on the other side, I can do that. So I could put equals 300 here, and then get rid of this. And then I could put the equals 480 here, and get rid of that. So it's the same thing, and some people really like it better that way, and that's totally fine. So we're going to go with that. All right, so again, I'm taking my 6L plus F equals 300, and then I'm going to get F by itself, which means I need to subtract that 6L. So those are gone, leaving me with just F equals, remember, not like terms, can't combine them. So I'm going to have my negative 6L and then a positive 300. So step 1 is done. Step 2, I need to take this expression and plug it into the other function. Now since I've got F equals, that means I'm going to take the expression on the other side of the equal sign and I'm going to plug it in for F. So then that means I'm going to start with my 12L plus F equals 480. And I'm going to take this thing and I'm going to plug it in for F. So I've got 12L plus F, which is actually negative 6L plus 300. And it's still going to equal 480. Now, I don't like having plus a negative. So we should know from algebra that plus a negative is the same thing as just minus. So I'm going to write that as minus 6L because it just looks more normal. Then that also tells me that I can combine those. So 12L minus 6L is 6L. Still have our plus 300, and it still equals 480. Now I'm ready to solve. So I'm going to get rid of the 300 first. Make sure I do it on the other side as well. And that gives me 6L equals 180. Then I divide by 6, and that gives us L equals 30. Yes, 30. Okay, so then once we have that, we're done with step 2. So then we can now figure out, we know the cost of each lesson is $30, and we can now figure out the cost of the one-time fee. So remember, we're going to take this and we're going to plug it in for L in our equation we got in step 1. So F is going to equal -6 times L, which is 30, and then plus 300. All right, so we have -6 times 30. Well, that's -180 plus 300. So grab your calculator if you need to, put that in, and you're going to get that F equals 120. So we now know everything we were asked to find. We know F, the cost of the one-time fee, was $120, and we know L, the cost of each lesson, was $30. So we're going to write and label our answers. So we're actually going to write in complete sentences. So the one-time fee is $120, and the cost of each lesson is $30. There we go. So then it is very clear what everything is when we write it in a complete sentence. Okay, so that is substitution. Next, we want to move on to elimination. I think I'm going to go ahead and stop it and do elimination as a separate video. So I will stop this and start a new one. So if you need elimination as well, then move on to the next video.